Find the determinant of the 3 by 3 matrix. The first row is 2, 1, 0. The second row is 0, negative 2, 4. And the third row is 0, 1, negative 3. To find the determinant of a matrix with dimension 3 by 3 or higher, we would need to use the minor and cofactor. The minor is defined to be the determinant of the matrix obtained by deleting the I row and the j column. So for example, if we use the entry 1, 1, then we would delete the first row and the first column. If we use the entry 2, 1, then we would delete the second row and the first column. Whichever entry that we use, we would need to cross out the row where that entry is and also the column where that entry is. Once we cross out the row and the column, the remaining smaller matrix will give us the determinant, which we call it the minor. The cofactor is the signed minor, either plus or minus, and the sign is determined by the position where the entry is. If the entry is 1, 1, first row, first column, then the cofactor 1, 1 is positive. 1 plus 1 is 2. Negative 1 squared is positive. If the entry is in the first row, second column position, 1, 2. 1 plus 2 is 3. Negative 1 raised to the third power is negative. And so, if the subscript add up equal to an even number, then the cofactor is positive. And if the subscript add up equal to an odd number, then the cofactor is negative. Any of the entry would have two subscripts. For example, the first entry, A, 1, 1, the subscript 1, 1, implies that the entry comes from the first row and the first column. This entry has a subscript of 3, 3, third row, third column. This entry has a subscript 1, 2, first row, second column, and so on. Let's call this matrix A. To find the determinant of the matrix A, we would use the minor and cofactor. The determinant is denoted by the absolute value of the matrix. If we use the first row to find the determinant of the matrix A, the entry in the first rows are 2, 1, and 0. We would take this entry and multiply the cofactor. Since number 2 is in position 1, 1, we would multiply the cofactor A sub 1, 1. Similarly, number 1 comes from the entry 1, 2. So we would need to multiply 1 with a cofactor 1, 2. And therefore 0 times A sub 1, 3. A sub 1, 1, 1, 2, 1, 3 are the cofactors. This is still a plus and a plus. 2 times. The cofactor A sub 1, 1 had the sign positive because 1 plus 1 is an even number. Once we cross out the first row and the first column, we end up with the determinant of the matrix negative 2, 4, 1, negative 3, plus 1 times. The cofactor 1, 2 has the negative sign because 1 plus 2 is an odd number, so we would need to multiply negative 1. Since we use an entry in the position 1, 2, we cross out first row and second column, so we would end up with the matrix 0, 4, 0, negative 3, and we would need the determinant of that matrix 0, 4, 0, negative 3, plus 0 times any cofactor is 0. This is 2 times The determinant of the 2 by 2 matrix can be determined using the shortcuts. Negative 2 times negative 3 is 6. 6 minus 4 times 1. Minus 1 times 0 times negative 3 is 0. Minus 4 times 0 is 0. And we do not need to write plus 0. And so this is 2 times 2 minus 1 times 0, which is 4. The determinant of the given matrix is 4. For this particular matrix, it is faster to use the first column because there are 2 zeros in the first column. The determinant of A is 2 times the determinant of the remaining smaller matrix after we cross out the first row and the first column, because 2 comes from the first row and the first column. Negative 2, 4, 1, negative 3, plus 0, plus 0. And this is 2 times 6 minus 4, which is 4.